Here in this problem, we want to show that cos squared theta plus sin squared theta is equal to 1. So let's see the solution to this. We will consider the right angle triangle we used earlier. And here we indicate this point to be point B, C, and A. If here is our capital letter A, here is B, here is C, we have here to be theta, and here is angle 90 degree. All right. So from this right angle triangle, we will consider a theorem called Pythagoras, and Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the opposites and that of the adjacent. All right, so that is the theorem. So the first approach is to divide both sides by c squared. If we divide all through c squared, the next thing we'll have is this divided by this will give us 1. And by sword, b squared over c squared can also be represented as b over c all squared. This can also give us that, plus similarly a over c all squared. All right. So by the time we go through what we've done earlier, b over c has a meaning. From the definition of sine, cos, and tan, we agreed that, or we summarized that b over c will result to sine theta. Because of the square here, add a square to it, plus a over c, we resulted at cos theta, and because of this square, we add a square to it. You can see that this can also be written as sine square theta. You can place a square on the angle, so it comes up here, plus cos square theta. So by symmetric function, we can reverse this to be the same thing as, so it looks like exactly the equation given. So if you reverse it, this can come up first, cos square theta plus sine square theta equal to 1. And this is the proof. We have other alternate method we can as well use in proving this, but this is fine.